بسم الله الرحمن الرحيم. رب اشرح لي صدري ويسر لي امري واحلل عقدة من لساني يفقهوا قولي. هنتكلم يا شباب ان شاء الله على الجالفانيك سيل. Galvanic cell, the idea start from galvani when you start to making anatomy for the frog. الفروج بتبقى على طبق التشريح واخده المنظر ده كده، فهو المفروض بيبدأ يفتح بالمشرط اللي معاه كده الفورسبس، بيفتح ويبدأ يشوف الأجزاء. فبدأ لاحظ إن will find the movement for the leg of the frog. In this period, Galvani said that the movement of the leg of the frog due to the electrical charge, and designed the first galvanic cell. This galvanic cell is a system work to change the chemical energy to electrical energy. Through spontaneous redox reaction. Spontaneous means that an electric current produces. What about the structure of the galvanic cell? Galvanic cell consists from the two halves, contain the two electrodes which differ in electrical potential, like when we insert the copper or zinc in zinc sulfate solution, zinc in zinc sulfate solution, and copper in copper sulfate solution, and we'll find an electrical charge produces from the zinc toward the copper. The galvanometer are pointed toward the copper. Why? Firstly, the zinc from zinc electrode, an oxidation process taking place for it gives to us zinc ion and the two electrons. These two electrons are moving the wire toward the copper. In this time, we'll find an increase, since the oxidation taking place, increase in the ions of the zinc that causes the increase in concentration of zinc ions. On the other hand, we'll find the copper in the copper sulfate solutions are reduced. Copper ions takes the two electrons come from the zinc and they change to the copper, solid copper precipitated at the cathode. So the anode are eroded and the cathode are increased in the mass. In this time, when the copper ion are reduced at the cathode, we'll find that the concentration of the sulfate ion is increased. An equilibrium taking place in the cell, and the EMF becomes zero. We'll find the pointer of the galvanometer, it becomes zero. To re-establish the equilibrium again and make the cell producing electric current, the Daniel are invent and modification. I will start to making a modification in galvanic cell. Daniel add the salt bridge. Salt bridge, it is a glass container, take the shape of U-tube. It contains an salty solutions from the sodium sulfate. Sodium sulfate and aqueous solution dissociated into sodium ion and sulfate ion. In this time, we will find the increase in zinc ions. So sulfate ions in the salt bridge direct toward this half, and the sodium ions direct toward this half. Sodium start to equilibrate the increase in the sulfate ions, and sulfate start to equilibrate the increase in the zinc ions, established again the equilibrium, and the electric current are produced. In the exam, you will find that established the cell and write the anodic protection or anodic reaction, anode, and cathode reaction. In this time, we will find the anode is the negative electrode, since it's producing the electric current, 2 electrons out from the oxidation process, and the cathode, it will be the positive electrode. What about the problems? It is the practical ended up till now. You will start to design an experiment by connect the copper with the red wire and the zinc with black wire in galvanometer. The pointer of the galvanometer, it's come to be millivolt. The pointer of the galvanometer is become at the millivolt. Okay? And they start to measuring the reading. حضرتك هتبدأ measure the reading. The reading it will be if the 1 molar concentrations from each solutions, 1 molar from the electrolyte, you will find the value of the EMF. It will be 1 or 0.97 volt. 1 or 0.9 volt. Okay? طيب. If I tell you in the problems بقى, في البروبلمز بتاعتها يا شباب, if I tell you that the oxidation potential or the reduction potential for galvanic cell from zinc and copper respectively negative 0.76 volt and positive 0.3 volt, 3 positive 0.34 volt. Find the EMF. In this time, what I will do?
What?
Okay. To determine the value of the EMF, the rule of the EMF equal oxidation of anode plus reduction of cathode. From where I can determine the anode and the cathode? Through this table, add zinc and copper, oxidation, reduction. I'll tell you then the problem that the reduction potential is 0.76 by the negative sign and negative 0.76 volt, 0.34 volt. The oxidation potential equal the reduction potential but by opposite sign, so it will be 0.76 volt, negative 0.34 volt. The higher in oxidation potential is become the anode. Who is the higher in oxidation potential? Zinc. So it is the anode. Type calculating the oxidation and the reduction potential. The higher oxidation potential it become the anode. طب والlower في الاكسيديشن potential او الهاير في الريدكشن potential هو الكاثود. حضرتك هتعمل كده. الهاير في الاكسيديشن potential 0.76. طب الهاير في الريدكشن potential اللي هو هيبقى الكاثود، يعني الزنك هيبقى الانود and the copper is the cathode. 0.76 plus 0.34 gave to us 1 volt.
مستر ممكن اقول حاجه؟ هو احنا ليه ما ينفعش نعمل ابسوليوت فاليو للفاليو اللي يتحنى من هنا وهنا، يعني الابسوليوت فاليو بتاعتي بلس الابسوليوت فاليو ويجيب نفس الناتج.
Okay, no problems. You'll find by any different way, but it's one from the ways is a very simple way you can use it. Okay, since you will find the EMF, it will be the different reduction potential or the different oxidation potential. Okay. طيب. Sometimes the concentrations of the ions in the cells are different, like in Nernst equations. Nernst equation. For another problems, okay, we're bringing the problem for the Nernst equation if we're having a different concentrations of the cells. In the following equation, Cu positive 2. If the value is become the EMF, it's become by negative, it means that there is no electric current produced. Okay? Cu positive 2 aqueous plus Fe in a solid give to us Fe positive 2 Cu solid. E naught for the cell equal 0.78 volt. This is value before changing the concentration, when the concentration was 1 molar concentrations. Okay? What the E of cell when 3 molar of copper and 0.01 molar of iron positive 2. Okay? And this time we're using the Nernst equation. Nernst equation, it will be E equal E naught subtract 0.05914. It is a constant value divided to log the concentration of ions of products divided ions of reactants. And this time we'll find the E naught for the cell 0.76 subtract 0.05914 divided 2 log the product is concentration of the iron, which was 0.01 divided the concentration of the copper 3. Calculate it, start to calculate it. Alpha X equal 0.76 subtract open bracket fraction 0.05914 divided 2 close the bracket log fraction 0.01 divided 3 close bracket shift solve equal, so we'll find the X equal 0.83, E equal 0.83 volt. Nernst equation will use that in the case of the differ in the value of concentration of the two halves. Okay, it is the end of the practical. We'll start now to make the practical. See you soon. Assalamu alaikum wa rahmatullahi wa barakatuh.